Okay, today's official title is called Rational Root Theorem. Okay, RRT. But I'm going to teach you the rational root theorem after I've reviewed with you a whole bunch of factoring. Okay, so let's just go back to the kind of the beginnings of factoring. 2x plus 10, simplest of all factoring problems. Factor it. I'm going to take a second to assign you to somebody in the room to check with. I'm going to pause for a second. Okay, so you should have just factored out the 2 and you got x plus 5. That's the first kind of factoring you did. Now let's move it up a notch. What if it has, let's keep it simpler than that though, x squared plus 3x plus 2. Very simple factoring with, I call it 3-part factoring because you got 3 terms. So you always just to make 2 parentheses. Factor that out, turn it and show it. Hopefully you got the same thing, and it should be like a easy peasy. You're supposed to be turning that way. There you go. All right, good. X plus 2, x plus 1. We good on that? Okay, moving on. What if it's like this? 2x squared. Try factoring that one. The thing that adds complication is the lead term is a 2. And so this number has to change. Other than that, it's done very similar way. Okay. Should have said 2x and x. At least you should know that, right? Now turn it and show it to the other person if you think you have it. Give them time if they need it. You don't want to show it to them if they're not done. Okay, would you agree this 5 has only 2 factors, 1 and 5? So that has to be a 1 and a 5. I don't know if it's there, though, or reversed. And I won't know until I try it. So I'm going to try it. I'm going to make this positive and this negative. And one of them has to be positive, one of them has to be negative to make a negative 5. Then how do you know if you're right? You check the outside and the inside especially and see if they make negative 9x. Does mine make negative 9x? No, makes positive 9x. If you ever get the exact opposite of what you wanted, you just have to make the signs the exact opposite. So the minus goes here and the plus goes there. Now it's negative 10 and positive 1 makes negative 9x. And to be extra sure, you can do the firsts and make sure it goes 2x squared, and the lasts and make sure that that makes negative 5. Okay, raise your hand if you're comfortable with that kind. Okay, next kind is where you go to 4 terms. And I just taught you that a couple days ago. Let's go with 3x to the third plus 6x squared minus 2x plus, or no, minus 4. This one will factor. And I call it, sometimes I call it 4-part factoring or divide and conquer. Remember doing that divide and conquer strategy? Factor the first part, factor the second part, and then put it all together. Pause for a second while you give that a shot. This one definitely had a challenging part because of the negative. That negative right there messes a lot of people up. You have to factor out the negative to make this work. So you have to factor out a negative 2, and that makes this become positive 2. If this and this ever are so close, but like one's got an opposite sign as the other, just go back and double check this part. You probably messed up this part if they aren't matching. All right. So this matches this, and now I can pull them out to the front, x plus 2, and whatever's left, which is this and this, go in here, 3x squared minus 2. Raise your hand if you feel confident on that kind. All right, good. Let's move on to 5-part factoring. We just did 4. Now here, move up to the 5 kind. 6x to the 4th plus 3x to the third minus 2x squared minus 3x minus 1. All right, so how in the heck are you supposed to do this? That's the point. Today, we tell you how to do this kind without any more help. In the past, what we would say is, check and see if 3 works. You know what I mean? We would tell you, and then you'd go like, oh, so I'm going to check and see if 3 works. 6, 3, negative 2, negative 3, negative 1. See what I'm talking about? But I didn't tell you what to check. I didn't tell you the 3 part. So that's the new thing for today, is to tell you how to figure out what to check. All right. I just wanted to preview that. Now I want to go to do some, the kind where I do tell you. I'm going to tell you x minus 2 is the thing I want you to check in this. X squared minus 4. I'll give you a hint. It has missing terms. Now there's 2 ways you could do this. You could do it with long, or you could do it with synthetic. Just don't forget the missing terms thing. Either way, because it has missing terms, it's going to be important to include that. Now, all of you are doing it with either synthetic or long. I would ask that you go through and do it both ways. So if you just did synthetic, then try it with long, because you have to be able to do both. I know you might think, well, I'm just going to always do synthetic. There's some kind that won't work with synthetic. So you have to know how to do long. Okay, so check it both ways, please. Do it with synthetic and do it with long. In any order you want, just do it both ways. And pause for a second while you try that and check with the kid next to you. Okay, just a little hint, because I see a few confused faces. I'm going to say, here's how you'd set it up for long. And then here's how you'd set it up for synthetic. Positive 2, remember. Because it's always, this is the factor, and the 0 for it, or the root for it, is whatever makes that, whatever you put in there to make it equal 0 as a total. So anyway, that's a positive 2 and a 1 and a 0 and a negative 4. So you're trying it both ways, the green way and the blue way. Okay, please check with those people that I assigned you to. I'll pause for a sec. Okay, so here's what you should have done. On this one, you'd say x goes here, x times x, x squared, x times the negative 2, negative 2x. Change both signs, opposite, opposite, and this is 2x. Then I drop down the negative 4, and I have 2x minus 4. Now I put something up here, probably a 2. 2 times x, 2x, 2 times negative 2, negative 4. It worked, because they're going to all cancel out and have a 0 remainder. So yay, I've got my answer. X minus 2 and x plus 2. All right, now, would it be faster to do synthetic? Yeah. Drop it like it's hot. 1 times 2 is 2. Add them, multiply them. Get a 0 at the end. You know, you're done. Cool. Then I bring this over, and I say this means x minus 2. And then I say this part right here is an x plus 2. And there we go. X minus 2, x plus 2. All right. So I want to go back to the original question here. And really the original question was, did x minus 2 go into x squared minus 4? And another way to say that was, did 2, see the root was 2, did 2 go into this? So back to the problem I said that we would eventually learn how to tell what numbers would work. We can ask ourselves that on an easier question. This one's much more complicated. But what if we had a simpler question like this? X squared plus 6x plus 5. What number could work for synthetic? Well, all you have to do is take the factors of the constant, which is this, and divide it by the factors of the lead coefficient. The lead coefficient here is a 1. I know it sounded really complicated, but what are the factors of 5? 1 and 5, right? and then you're dividing by 1. Well, it means divided by 1 doesn't really change anything, right? So all it means is 1 and 5 are the only things you could put in here. Either check a 1 or you could check a 5. But you could use the positive or the negative of both of them. Okay, so it could be -5 that works, or it could be +5 that works. It could be -1 that works, or it could be +1 that works. And here's the other thing. You would never, ever want to divide by a, well, no, that's not true. I'm wrong. You would sometimes want to factor out a 1, because what that really means is you're factoring out an x minus 1 out of the thing. So I'm sorry, you would want to divide by a 1. My bad. Okay, so back to your two choices are either 1 or 5. I'd like you, even though I'm sure you know how to factor this the old school way. In fact, go ahead, factor that the old school way. You'll know what the answer is, and that's okay. Then I want you to use synthetic, even though I haven't told you what to check. I just showed you how you could figure out what number to use for synthetic. So just factor it old school. Hopefully you've already got it. And then try doing the synthetic thing on it. A lot of you will realize you're testing the wrong thing. All right, you should have said x plus 1 and x plus 5. Do you agree? Okay, then, really, should you be testing 1 or 5? Nope. What should you be testing? -1 or -5. And if you test -1, test -1. See if it works. One, 6, 5. Drop it like it's hot. Go from there. And then test -5. I'll do that in red over here. 1, 6, 5. Drop it like it's hot. I'm going to pause for a second. You get your conclusion, and then you talk with the person I assigned you and see if your conclusion is the same as theirs. When you did it both ways, what did you figure out? I'm going to pause for a second. All right. I hope you realize that when you work this thing out, you end up getting it to work either way, and your answer comes out identical. It's just they're reversed. Instead of an x plus 1 at the beginning like this one has, you end up with an x minus 5 at the beginning. And again, -5, 1, -5, 0. It's just reversed, but it's the same exact answer. Okay, good. So now we were practicing on an easy one. All right. And what did we figure out? I hope you starting to figure this out. It's the factors of this. See, we used 1 and 5. Whether it's positive or negative is a guess. You just have to try it. Yes. Yes, you may. So on this one right here, we now have to decide what its factors are. What are the factors of a -1? All right, you're not paying attention. Focus, focus. What are the factors of a 1? 1, that's it. That's the only thing. But this is a little more complicated than just what are the factors of the last number. Write this down. FCON, FCO. That stands for factors of the constant over factors of the coefficient. You're not writing. Are you psychically writing? Okay, good. You're just incredibly fast. All right. Factors of the constant over factors of the coefficient. All right. So here is an example. I'll give you a more normal one. 2x squared plus 3x plus 7. If I was going to check and see what synthetic number to use, you know, like for this kind of a synthetic problem, I would need to look at the factors of the constant This is how those synthetics always start, right? What number do I put here? Well, 7 is a possibility because I use the factors of the constant over the factors of the coefficient. What are the factors of the constant? 1 and 7. What are the factors of the coefficient? That's this thing in front. 1 and 2. Then you divide them. That's why I had you put them on top of each other, because it's actually a divide. And you divide everything by everything. Everything on top divided by everything on the bottom. What's 1 divided by 1? It's 1. What's 7 divided by 1? It's 7. What's 1 divided by 2? It's 1/2. And what's 7 divided by 2? Yep. Or 7/2. Those are the 4 things. And then you have to check the positive and the negative of all of them. This is your list of all the possible factors. That is a typical homework question for today. It's what are the possible roots of this equation? And you got to take f con divided by f co. What does that mean? That means if I take this equation and now I check 1, it could possibly work. 1, 2, 3, 7. I'm going to double check it. Drop the 2, multiply, add, multiply. Did it work? Nope. Now I got to check -1. 2 comes down here, -2, 1, -1. Did it work? Nope. So then you check 7. 7. Drop this. Oh, sorry, 2. 2 times 7 is 14. Can you tell right away it's not going to work? Because this is going to get bigger and bigger. When you multiply and add, that's not going to work. So do you get how if you multiply and add, it's probably never going to work? You'd need a negative. Maybe it's -7 that will work. So you drop this 2. 2 times -7, -14. Add them together is -11. Multiply them, +77. Holy cow, that didn't work at all. What's going on? Nothing seems to work. If nothing works, what's the answer? Yep. That's the only way you could solve this one. It won't factor. Is it possible that none of the things work? Yup. Now on the test, I don't think we would give you one of those because kids go insane. They check them all and they think that one of them must have worked, and then they check them all again and they still don't all work, and then they just wasted 15 minutes and they find out nothing works. So we're going to probably give you ones that factor. Okay, but it is possible. It's just in the real world, this thing doesn't factor. Try it all you want, but it never will factor. But these are the things that were the only possibilities. Okay, now I'm going to give you one that actually does factor. 2x squared minus, let me see what that was again. 9x minus 5. That one for sure factors. It's not very fun to factor. What I want you to do is f con over f co. Get yourself a list of the possibilities, then pick off that list what you think is most likely and do synthetic, and something is going to work. F con, f co. Figure out what the possibilities are, and pick from your list, and then try something synthetic, and something's going to work. And please, once you found it, don't say, oh, 5 works. I want you to wait until people have a chance to do it for themselves. Okay? Try to figure out what is the possible list. Choose some stuff. Try a few. Eventually, it's sort of like finding gold. You're like, ah, this one actually works. Yes, I factored it. I'll pause for a second while you try. Okay. So, I know it's kind of cheating, but maybe you could save me some time. I know the factors of the constant are 5 and 1, and the factors of the coefficient are 1 and 2, and so therefore it's 5 over 1 is 5, 1 over 1 is 1, 5 over 2 is 2.5, and 1 over 2 is 0.5. Could you tell me which of those 8 things you found to work? Get how there's 4 things, but then you double it because it's plus and minus? What worked? Positive 5? All right, I'll prove it, or not prove it. 2, negative 9, negative 5. Drop the 2 down. 2 times 5 is 10. Add them 1. 1 times 5 is 5. It worked. It's got a remainder of 0. Yay. So therefore, I have, bring this down, x minus 5, 2x minus 1. There we go. Now, I ask you, do you think that this is a, now that you know how to do it, do you get that this might be a fairly good way to factor complicated things? It's really not that bad. I think it's probably faster than guess and check with 2x and x. You know what I mean? That works, but this way was probably better. I don't know. It's an opinion question. All right. So what, of course, it turned out to be is 2x minus 1 and minus 5. There we go. Okay. So you've learned what's called the rational root theorem. Now let's get into your homework. Everybody find the homework for today, and let's do some of the first couple problems together here. It's in here. It's called Lesson 5 Rational Root Theorem Worksheet. And I'm going to go download the file so I can do it in PDF form. Okay. Oh, come on. There we go. Okay. Notice this whole first thing is just it's an example problem. Don't think, oh my gosh, this is so complicated. It's just an example problem. It shows you how to do it in case you didn't totally understand it. It works one out for you. Tells you here's the possible answers right there. Positive 1 and negative 1, positive and negative 2, and positive and negative 4. That's the answers to this one. Those are the possible roots, the things you could check. All right, for 1A, please don't make the mistake of thinking on this that you actually factor these. You do not have to factor these. You have to just list the possible factors. So if I were you, I'd go F con over F co. I wouldn't even write that every time. I'd just do the constants on top and the coefficients on the bottom. Factors of the constant is 2 and 1. The factors of the coefficient is just a 1. And then I take all the numbers on the top and divide by the numbers on the bottom. 2 divided by 1 is 2. 1 divided by 1 is 1. So it's 1 and 2. And don't forget to plus and minus in front of that. Technically, it'd probably be better if you put plus and minus 1 and plus and minus 2. But I just don't want you to have to put plus and minuses all over the place. Something like that's another way to write it. Okay. All right, this one. Factors of the constant, 3 and 1. Factors of the coefficient, 1. 1 divided by 1 and 3 divided by 1, it's 1 and 3. The common mistake would be to forget the plus and minus. Okay, get the idea? All right, A, B, C, and D are the only ones where you're actually doing the thing of the day, finding the possibles. Okay, F con over F co. So I want you to do A, B, C, and D on number 1. But in section B, given that I'm not giving you much work time today, I'm going to allow you to skip problems. Problem D is in donkey, and on problem 3, you can skip C as in cat. This is one we didn't talk about very much. In fact, I want to go and do a problem like that on the side because, man, a lot of people got that one wrong. I don't want to do this one off your homework because you need one to practice on your own. But would you please get back to a notability? I'm going to show you one more kind that a lot of kids got wrong on the test last year. A lot of kids. And it goes x to the 4th plus x squared minus 2. All right, if it's 3-part factoring, then you can just do it with 2 sets of parentheses right away. Or you can do the thing we just learned 2 seconds ago. What are the possibles that you could use on synthetic on this? Just tell me what it probably is. 2 or 1, right? Because it's the factors of the constant, factors of the coefficient. So it's probably a 2 or a 1. Try a 2. But remember, there's missing terms on this. So many people got this wrong. I think it was because of the missing terms. There's 2 missing terms. One, 0 to hold the place for the x to the thirds that aren't really there. And then about the x's that are not really there, we'll have to hold their place too. 1, 0, -2. I think it was because of the missing terms that really goofed people up. Anybody got this one? Did it work or not? All right, I'll double check you quick. Dropping this, 1, 2, add them, multiply them, add them, multiply them, add them, multiply them. Yeah, 20 is going to be way too big. So, okay, 2 didn't work. 1 something works. Keep trying. Keep trying until you find it. Do you get how it'd be a pain in the neck, but you can eventually find it? It's either 2 or 1 or -2 or -1. I tried 2 and it didn't work. Now I'm going to try -2. Oh, -2 didn't work. Okay, what's next? Try 1. 1. Oh, it's confusing. There we go. Hey, it worked. So what's the answer? The answer is, bring this 1 down, x minus 1 times all that, and this is the x's, x squareds, x to the thirds. Final answer, that, oh, sorry, plus, plus, plus. And I can just see a kid getting to this point and going, yes, I figured out the really hard one. And then being wrong. Because you didn't factor it all the way. Do you get this is a divide and conquer kind? Factor it all the way. Finish it. That's what the test is like. We still have 2 days to review for it, Monday and Tuesday. Quiz is coming, or test is coming on Wednesday. Good point. You do have the weekend where you can practice too, but I mean class days, 2 more class days of review. X minus 1 comes all the way down. This one, I'm going to do it divide and conquer way, so I'm going to go x squared comes out of this, and I got x plus 1. 2 comes out of that, x plus 1. Then, final answer. And then, I hope you by now have gotten burned enough times that you would take a second and look and see, can that factor any more? Can it? No. So, we are done. And this is the final answer. Can you tell me, would this have any real roots? Yes, it would have real ones. Would it have any, now think before you answer, would it have any imaginaries? Yes, it would. Because this part right here, that kind is the kind that give you imaginaries. X squared plus 2 equals 0. X squared equals a negative. When you take a square root of a negative, you will have imaginaries. Okay? Final answers, the reals. X equals 1, x equals -1. The imaginaries, plus and minus, you will always have a plus and minus. If you're going to have an answer for imaginary, it's going to have a plus and a minus. Why? Because you always are going to have a square root of a negative, and the square roots always come from the quadratic formula, which has a plus and a minus built into it. Or another way to say it is, you'll have an absolute value of x, and it's I root 2, so it's plus and minus I root 2. There we go. So, you're earning your honors status. This is not something that you would be doing if you were in regular. You couldn't, well, I'm not saying you couldn't handle it. If you'd have been in a regular class, you could have handled it. But it's not something they teach. Okay. They teach it up to some point, but you're going to go further. You do the harder ones. All right. So, your homework for tonight includes one of those. I just wanted to take a second to show it to you there. So go back here. It's right there. It's going to be a lot like the one we just did 2 seconds ago. On this one, just to clarify, oh yeah, you were skipping C on this one. You see how this thing has an X and everything? You can just factor that out right away. Save you a bunch of time. X squared comes out, you know, of everything. So this particular one was a pretty easy one. All right. Now, the only reason I'm having you skip a few problems here and there is to save you time. For those of you that are like, you know what, I need to practice. I'm not very good at this thing. Then you should just not skip the problems I told you could skip. Go back and do them for practice. Now, it's not required. We have 2 days of review coming up, which is why I feel okay about having you skip a bunch of these. All right. Let's look a little further in section D. Pausing for a second. That's all the time we have for today.